All right, guys, welcome back. This is Unit 1, Topic 4, and it's all about operations with rationals and just being mindful of what a rational might look like. It just comes in this form where, just a general form, this is irrational, and just being mindful that y is always referred to or also referred to as f of x or just some function, right? So just an overview what's gonna be happening here. We have 5 total sections. One's gonna be adding and subtracting rationals. The second's gonna be multiplying and dividing rationals. Thirdly, we'll be simplifying complex fractions. Fourthly, solving rational equations. And the last thing we want to do is work on solving the inequalities of these rationals. So for the types of discontinuities, when you look at this, as a reminder, I like to go ahead and put some numbers in there. So here's -2, here's -4, -6, and -8. Here's 2, 4, 6, 8, and 10. So that just helps me look at this a little bit more clearly. And when we're trying to decide how to go about doing this, at -8, this is -8. They're going in opposite directions. So this is an infinite discontinuity. It's infinite, right? At -6, we have a jump. At 5, we have another jump. At -2, we have a jump. At 1, we have a removable. At 2, we have a jump. At 6, we have a jump. And at 8, we have our last infinite discontinuity. All right. So just moving on to operations with rational expressions. When we're doing this, we want to focus on my goal here. 2 goals. One, same denominator. I need the same denominator. And then number 2, combine like terms on the top in the numerator. All right. So when we're to get the same denominator, we use multiplication, and then we combine. So here, I need this 3 and a 7 to be the same. The way I do that is to multiply the bottom. So I multiply 7 over 7 times the first portion plus 3 over 3 times the second portion. And what ends up happening, the great thing about multiplication with these rationals is it just makes things a lot easier. So 7 times 2 is 14, plus 3 times 4 is 12, and on the bottom I have 21. This gives me 26 over 21, and you're done. So if I were to do this on the other side, at the bottom we have x plus 1 on one group and x minus 1 in the other group. So what would this look like? So you would have x minus 1 over x minus 1 times 3 over x plus 1. And typically, you don't really need to do a lot of work here with the multiplication, with the simplification at the bottom. But over here, I'm going to say x plus 1 over x plus 1 times that group. Okay? So what does this look like? So at the bottom, I'm going to have x minus 1 times x plus 1. The order doesn't matter. The order in which you put these things in the denominator don't really matter. But at the top, that first group, remember I'm distributing this 3 to two different terms. So I have 3x minus 3. And then over here on the right, I have positive 4x plus positive 4. Then I combine like terms. I have 7x plus 1 over x minus 1 times x plus 1. And you need not simplify that. If you wanted to, you could, and you end up with 7x plus 1 over x squared minus 1. Okay, don't have to though. Let's look at number 2. Same type of stuff, so 6 over 6 on the left plus 5 over 6 times 2 over 2 on the right. Now, one of the things you could do is you don't actually have to multiply 6 over 6. You could just work to make them the same. So I'm going to go back because the more things that you change, the more likely you are to make a mistake. So if I wanted to make the bottom the same on the right, so I could just multiply a 3 here. I can multiply a 3 here. So a 3 over 3. See, 3 times 2 is 6. I end up with 9 over 6 plus 5 over 6. And as we can see, denominators are the same. So I have 14. And the reason we want to do that is when we get bigger groups, we want to do the least possible. So if you notice, x plus 3 is in both groups. So the only thing I have to kind of change here is to multiply x minus 1 on the top and bottom over here. So what do I mean by that? So x minus 1 times 2x over x plus 3. And this would get me to have the same thing for both in the denominator, right? So 4x over x minus 1 times x plus 3. So let's work and see like how we can be sure about this. So we get 2x squared. So 2x times x is 2x squared minus 2x's. Then I have x minus 1 times x plus 3. And if we look, we have the same group now on the denominator. I did some fancy combining or multiplying those groups, but we have the same thing in the denominator. And now that's all that's left is I can create a little line right here. I can go over that and bring a positive sign up. And I have 4x and 2x as like terms. So end results 2x squared plus 2x over x minus 1 times x plus 3. Let's look at the last part. So we have no common factors in 5 and 6. So that means I have to multiply 6 over here minus 1 over 6 times 5 over here. Get 42 over 30 minus 5 equals 37 over 30. And I'm done. Let's look at the last one here. I get x minus 1 over times 2x over x plus 3. And it guarantees that I'll get this denominator here, x minus 1 times x plus 3. And on the right, I have negative 4 over x minus 1 times x plus 3 over x plus 3. I'm going to simplify. I get 2x squared minus 2x minus 4x minus 12. And that gives me the opportunity to say that this is 2x squared minus 6x minus 12. Yeah, you could factor some stuff out, but we're gonna leave it right there. We're gonna leave it right there. Um, you could definitely factor some things out, but that's all she wrote for that. And things to be working on right now would be the classwork. Um, just being mindful, need the same denominators. If you need support with this, let me know. I'll help you. And for tonight, you do have homework. Make sure you take a snapshot of this page, submit it, and this page, and submit it. Okay? Next class, we will be looking at multiplying and dividing rationals. Have a great day, guys.